You know how sometimes an idea just grabs you, whispers, hey, the future's kind of here.
Uh-huh.
That's exactly what happened when I started digging into this thing about world models.
Yeah.
I mean, we're talking technology that feels like it's straight out of science fiction.
Yeah.
You know, the holodeck, the Oasis.
Right. Machines that can generate entire realities basically on demand.
Exactly. And I'm guessing that possibility, well, it sparks your curiosity too, right?
Oh, absolutely. It's a really compelling idea. An AI that doesn't just make a picture, but builds a whole simulated environment and understands physics.
That's
Yeah, it opens up so much.
Totally. So, yeah, for this deep dive, we're going to explore these world models. We're basing this on a really interesting article from Andreessen Horowitz. And our goal, it's pretty straightforward. Let's try and get a clear handle on what they are, how they work, and, you know, the important bit, why they matter. Whether you're deep into tech, or maybe in a creative field, or honestly just fascinated by what's coming next.
Makes sense. Cutting through the jargon.
Yeah, let's cut through the jargon. Focus on the potential, the impact on it, like how we learn, create, interact with digital stuff. Okay, so let's unpack it. Simple terms first.
Yeah.
What is a world model exactly?
Okay, so at its core, a world model is basically an AI, right? But it's designed specifically to generate virtual environments.
Okay.
And it has this inherent understanding of how the physical world works. Think about ChatGPT generating text or Midjourney making images.
Yeah.
World models do that, but for spaces, entire spaces.
So wait, instead of just getting like a picture of a room, you're getting the actual room, the environment itself.
Precisely. And it's not just static visuals either. That's the key.
Right.
These models can simulate the dynamics within those environments. So how objects move, how they interact, even environmental changes like, weather shifting or time passing.
Oh, wow.
And they get physical forces too, which means you can interact with the simulation in a way that feels, well, believable, kind of like a video game where your actions actually have consequences in that world.
Okay, I'm starting to get the scale of this. It's not just making pretty 3D scenes, it's building these interactive, almost living digital worlds.
That's a good way to put it, yeah. Living digital worlds.
Now, the article made a point that this isn't just some far-off dream. It said world models are actually showing promise already, like in real-world applications, especially for people working with space, physical, or virtual.
Absolutely. The immediate benefits are pretty practical, especially if you're already using things like game engines.
Okay, like give us some examples. What does it look like right now, or maybe very soon?
Sure. So think about robotics engineers. They can use these simulated environments to train AI for robots. Test out all sorts of scenarios, difficult situations, without risking damage to expensive hardware or causing chaos in the real world.
Makes total sense. A safe sandbox for robots.
Yeah.
What other areas?
Film studios are another big one. Imagine creating entire virtual production sets. Filmmakers could experiment with layouts, camera shots, lighting, all before building anything physical. Saves time, saves money.
Yeah, I can see that. And games.
Oh, huge potential for game developers, building incredibly detailed, responsive worlds. The article even hints at this idea of the never-ending game.
A game that just keeps generating itself. That's wild to think about.
It really is. Then you've got XR creators, augmented virtual reality experiences, architects designing buildings.
How would an architect use it?
Well, they could virtually walk through their design, see exactly how the sunlight hits a specific window at 4 p.m. in June,
Okay, that's specific and useful.
Very. Urban planners could simulate whole cityscapes, check traffic flow for a new development, interior designers visualizing layouts for clients.
So it's really about experiencing and interacting with spaces before they exist, or in ways you couldn't otherwise, whether they're real-world plans or totally virtual concepts.
Exactly that. And like you said, the article suggests the really groundbreaking stuff might be things we haven't even thought of yet.
Right, the unexpected applications that always seem to pop up.
That's usually how it goes with new tech.
Okay, so the article then dives a bit deeper into the how.
Yeah.
It talks about two main ways they're building these worlds. Native 3D and video-based models. Can you break down the difference for us?
Sure. The fundamental difference is really in how the model represents and generates the environment. So native 3D world models, they're built with an inherent understanding of 3D space right from the start.
Okay.
They take a prompt text, maybe an image, and they generate a structured, explorable space. It has actual depth, objects persist, and you can interact with things in a physically plausible way.
So it's genuinely building a 3D structure, like behind the visuals.
Yeah, you can think of it like that, almost like creating a digital twin of a space, but generated by AI. And this approach is really useful for things where that solid spatial understanding is crucial. Like game development, you need consistent navigation. Objects need to behave properly. Or industrial design, where precise measurements matter. The article mentions a company, World Labs, and their tech that can apparently take a single image and turn it into an explorable 3D environment in real time, which is pretty impressive progress.
Wow, okay. Take a photo, walk around inside it. That sounds powerful. But the article also pointed out some pretty big challenges with this native 3D way. What are the main hurdles?
Well, one huge one is just the complexity. Generating coherent 3D geometry that also looks good and behaves realistically according to physics, that's computationally very, very demanding.
I bet.
And then there's the data problem. We have tons of images, tons of video to train AI, but high-quality, large-scale 3D data, much scarcer.
Oh.
And even the 3D data we do have often isn't labeled well enough for AI training. It's hard to automatically tag everything in a complex 3D scene.
So not enough good training material.
Pretty much. Though, interestingly, the article mentions a potential workaround using video. Like, if we can get AI to generate really good videos of objects, maybe we can use those videos to reconstruct the objects in 3D for training the 3D models.
Oh, that's a neat idea. Using one AI to feed another. What about actually using these 3D models, the interface side?
Yeah, that's another challenge. Professionals, like architects or designers, need fine-grained control. They need to tweak lighting on the fly, change the time of day, maybe the weather.
Right, not just accept the first generation.
Exactly. Precise camera control is key. And, maybe most importantly, they need to be able to modify individual things after the world is generated. Change a wall texture, move furniture around, without having to start over.
And that's hard to do currently.
Getting that level of granular, interactive control in a generative system is still a big research area.
Okay, makes sense. So that's native 3D. Let's switch gears to the other approach. Video-based world models, how are they different?
They take a fundamentally different tack. Instead of building an explicit 3D structure, they work by generating dynamic, unfolding sequences, essentially predicting future video frames.
Predicting video frames?
Yeah, based on the frames that came before and any input from the user. Think of it like the AI is continuously painting the next moment of a scene based on what just happened and what the user wants to do.
So it's more about creating a convincing interactive movie than a true 3D space with underlying geometry.
Exactly. Their strength really lies in things like narratives, cinematic experiences, stuff that evolves over time, where the focus is maybe more on the visual flow.
Okay.
And they have an advantage because they can learn from the massive amounts of video data out there. They can observe how things move, how physics seems to work in the real world, just by watching videos.
But isn't the data source for that a bit murky, copyright-wise?
Well, yeah, the article touches on that. It calls the copyright status a murky gray area, which seems accurate for a lot of AI training data right now. But it also mentions partnerships like Lionsgate, working with Runway, as maybe a path forward, collaboration,
Right, finding ways for content owners and AI companies to work together. Okay, so the article gave some cool examples of these video models, like Google's GameGen and Oasis.
Yeah, GameEngine was an early demo, basically an AI-generated playable version of the old game Doom. Pretty cool.
Wow.
Then Descartes Labs came out with Oasis, doing something similar but for Minecraft. They put up a web demo, and apparently like 1 million people tried it in the first 3 days.
1 million in 3 days?
Yeah. People could actually interact with this AI-generated Minecraft world, chop trees, fight zombies, the usual stuff.
It's amazing.
And more recently, Google announced Genie 2, which can generate a playable environment from just a single image.
From one picture, you can play in it.
That's the idea. And another company, Odyssey, which already has a 3D model called Explorer, is apparently working on a new real-time video world model too. So there's a lot happening.
It sounds incredibly promising, generating a playable game from an image. But the article also talked about a key trade-off with these video models, something about consistency. Memory.
Right. That's the big challenge here. Because they don't have that explicit 3D structure underneath, they rely entirely on what they've learned from videos to keep things coherent from one frame to the next. And they can struggle to, remember everything they've generated over time.
Like it forgets what it just showed you.
Kind of. The article uses Oasis as an example. You might turn around, look away for a moment, and when you turn back, the landscape has changed.
Whoa.
It's like the model doesn't have a persistent memory of the space. Imagine playing a game where the map keeps shifting, or you pick up an item and then it just disappears later.
Yeah, that would break the immersion pretty fast.
Yeah.
So how are they trying to fix this memory problem?
There are a few interesting approaches. One is using something called Retrieval Augmented Generation, or RAG.
RAG.
Yeah, think of it like giving the AI a searchable database of past frames, like a photographic memory. It can constantly check to stay consistent.
Okay, that makes sense.
Another technique uses recurrent neural networks, RNNs. These networks have a kind of internal state that lets them remember information from previous moments in the simulation, like remembering that your character picked up a key.
So trying to build in that persistence.
Exactly. Overcoming these memory limits is really crucial to make these interactive video models work for anything complex or long-lasting.
This is really fascinating stuff. So, okay, we have these two main paths,
Yeah.
right? Native 3D, great for spatial accuracy, but data and creation are tricky. Video-based, amazing for dynamic visuals, but struggles with memory and consistency.
That's a good summary, yeah.
Now, the article then shifts to something critical, interfaces. If we're actually going to use these things effectively, how do we interact with them? What are the challenges there?
Oh, interface design is a huge piece of the puzzle. It's a major hurdle.
Why? What's the issue?
Well, you've got this tension, right? On one side, you have super powerful professional tools like Unity or Blender. They give you incredible precision, but you need serious expertise to use them.
Right, steep learning curve.
Definitely. Then, on the other end, you have these simpler text-to-world approaches. They're easy to start with, type a description, get a world, but they often lack the fine-tuned control you need for real applications.
So we need something in between, or something new.
Exactly. The article argues we need a new generation of user interfaces, AI native interfaces, built specifically for generative world models.
AI native UIs. What would make them different?
They'd need to be much more adaptive, more context-aware, offering controls that make sense for who is using them and what they're trying to do.
Can you give an example?
Sure, an architect might need tools focused on spatial rules, maybe building codes. A filmmaker needs dynamic controls for lighting, mood, atmosphere. A game developer needs ways to track game logic, ensure interactions work consistently.
So tailored controls for different jobs.
Right. Industrial designers might need really granular object manipulation. The core idea is to bridge that gap between a user's creative vision, what's in their head, and the detailed steps needed to make it real.
Making it more intuitive.
Yeah, potentially supporting different inputs too, texts, sketches, maybe even bringing in existing 3D models. The article even mentions blending the precision of traditional tools with something called vibe coding.
Vibe coding, what's that?
It's sort of an intuitive, feeling-based way to describe what you want, sometimes using tools like Blender. Less about exact parameters, more about the overall feel. The goal is really to empower more people to create, to close that gap between imagination and making something tangible.
Okay, moving beyond just typing commands. More like guiding and refining the world. That sounds promising. Now, the article also talked about how people are actually starting to use these models today. It drew a parallel to how we use things like ChatGPT or Midjourney, this idea of knowledge out versus creativity in.
Yeah, that was an interesting framework they observed from talking to early adopters.
Can you explain that knowledge out first?
Sure. Knowledge out is basically using these generated worlds to learn more about the real world.
How so?
Think back to the architect example, generating the building to see how the real sun will affect it. That's gaining knowledge out of the simulation. Or the industrial designer analyzing patient flow in a virtual hospital layout to improve the real one.
Okay.
Or that robotics engineer training a virtual guide dog in a simulated city before taking it out on real streets. They're extracting understanding about real-world complexities.
Got it. Using the virtual as a test bed for the real.
So what's creativity in?
That's using the world model more like a creation tool to bring your own ideas into existence, similar to using Midjourney to visualize something you're imagining.
Okay.
So a game designer could use it to quickly prototype a level idea. A filmmaker could mock up a scene to nail down the mood or camera angles. Maybe you could even preview a travel spot in XR before you book the trip.
Ah, okay. So one is analysis, the other is synthesis, kind of.
You could put it that way, yeah. Analysis versus creation.
And the article suggested that while some jobs might lean one way,
Right, architects might lean more knowledge out, game designers more creativity in.
most people will probably end up using both. And the really cool stuff is still to come.
Exactly. Like with the internet, the most revolutionary uses often come later, once the tools are widely available and people start experimenting in ways the creators never predicted. They think consumers might drive early adoption with new kinds of experiences, and then professionals will follow as the precision gets better.
Which kind of leads to what I thought was one of the most mind-bending parts of the article, this idea of completely new experiences and the lines blurring between digital and physical reality.
Yeah, that's where it gets really profound. If these models reach their full potential, the boundary could become much more fluid, more experiential.
What does that mean? Experiential. Instead of just watching a film, imagine stepping inside it. Instead of playing a game with set rules, you explore a world that genuinely reacts to your choices, remembers what you did. It becomes less like playing, more like inhabiting.
Yeah.
They compared it to immersive theater, like Sleep No More, where the audience wanders through the set and pieces together their own story.
That's a powerful comparison. So how does this change things like work?
Well, the article paints a picture where work becomes less about staring at screens and manipulating abstract data, and more about interacting with ideas as if they're already tangible. Architects literally walking through their unfolding designs, urban planners simulating a whole city in action,
Defense strategists.
running reality-scale simulations, engineers testing prototypes in dynamic virtual environments that mimic the real world perfectly. It's a shift, they suggest, from screen-based interaction to inhabiting these digital or blended spaces. AR, VR, physical reality, the lines just get fuzzier.
It's moving from interacting with tech to living within it. That feels like a fundamental shift.
It really does.
Okay, but if we're talking about these potentially infinite, super immersive worlds, how do they make money? The article mentioned worlds as a service and economies of imagination. What's the thinking there?
Yeah, the business models are definitely still up in the air, but the suggestion is a move away from owning static digital things like buying a game,
Right.
towards paying for dynamic experiences. They floated the idea of a generative digital theme park, like a real oasis, where maybe you pay by the hour to explore a world that's constantly being created just for you.
Pay-per-hour exploration.
Could be. It might make really ambitious, immersive projects that mentioned Disney's Star Wars Hotel, the Galactic Star Cruiser, maybe more economically viable if they could be generated and personalized more easily.
So subscriptions, maybe.
Yeah.
Subscribe to a platform that makes unique worlds.
Exactly. A filmmaker subscribes to generate narrative worlds. An urban planner subscribes for simulation tools. A traveler subscribes to explore procedurally generated destinations.
But if there are infinite worlds, how do you find the good ones? What are the ones you want?
Ah, that's the billion-dollar question, right? Discoverability. The article stresses how crucial sophisticated recommendation systems will be. Systems that don't just know what you like, but understand your nuanced emotional and creative desires. What kind of wonder are you looking for right now?
That sounds hard.
Extremely hard. Successful platforms won't just generate worlds. They'll need to curate wonder. They'll need an ecosystem. Creators designing the recipes for worlds, users subscribing, and these incredibly smart recommendation algorithms connecting them.
So the surrounding infrastructure is key. Which brings us to the end of the article, really. Building that future ecosystem. They said the tools and interfaces are just as vital as the models themselves.
Absolutely. The core tech is amazing, but it's the ecosystem that makes it usable and useful. They drew a parallel to game engines like Unity and Unreal.
How so?
Those engines didn't just enable big studios. They democratized 3D creation, put powerful tools in the hands of smaller teams and individuals. We'll likely see the same thing here, companies emerging to build the specific tools, the intuitive interfaces, the applications that let creators actually use world models effectively.
So it's about the whole package.
Yeah. The first steps are combining these powerful models with really thoughtful interfaces and creative applications built on top. And the authors seem most excited, really, about the things we can't predict yet, the unexpected ways people will take this tech and run with it.
Just like with the internet itself. It wasn't just the network, it was everything built on the network.
Exactly.
Okay, well, this has been seriously insightful, a real deep dive into world models. For me, the big takeaway is just, this feels like a major leap towards creating genuinely interactive, dynamic digital realities. And the ripple effects can be huge across so many fields. And we got a good look at the two main flavors, native 3D and video-based, and the pros and cons, the challenges each one faces.
Definitely. And it leaves us, and you, the listener, with a pretty big thought to chew on,
Yeah.
Raphael. Well, thinking about this potential for, like, infinite personalized worlds, what kinds of experiences do you think will be the most transformative? And maybe just as important, what new challenges does all this abundance create for us, as individuals, as a society?
That's a good question. What does infinite choice do to us? Lots to think about regarding creativity, work, how we relate to the world.
Exactly. How we interact with reality itself as these lines keep blurring.